Good evening. As you can see on this session, I'm going to explain the programming language C. So welcome to C programming language. And this is my Linux machine that I'm just showing with this banner, welcome to C programming language. So on this, I'm going to clear my screen. I'm going to do a PWD. First, I need to show you what operating system I'm using. As you can see, I'm on a Linux Ubuntu 20.04. The reason I'm showing you the operating system long-term support of Ubuntu is because I'm going to compile this one with using the GCC compiler because it's a C program. So without further ado, let's look at the current working directory. I'm on a home wlutfi programs. And if I look at all the .c programs, I can see this is a Linux command ls-l star.c. It shows all the programs that I have pre-written. And then I'm going to demo these ones on this session today. Mostly the while loop, the for loop, and then the hello program. The infinite loop is also basically within a for loop. I could show you as well as that one. It's not a problem. So, and then let's just go. The reason I'm saying the infinite loop is not a problem because I have done this one on the advanced shell programming already. And I demo with the G core and then other stuff with ELF and executable file, how you just look for a program when it is infinite loop, it is never completed, and then how you terminate it and all that things. But I watched my video chapter 4, advanced Linux shell scripting, part 8 of 8. That one explained this ELF and executable link format, as well as the infinite loop, and as well as G course. If you go on MyWebUniversity.com, obviously that's this video right here. Linux Advanced Chapter 4, Part 8 and 8. So you're welcome to subscribe at our channel. And then if you make any comments and any improvement needed to help you further, I'll do so. And just make a comment, say I needed this to be explained differently, or just add some comments. Whatever area that you need the most help, I'll work on that area for you. Thank you so much for your comments, as well as watching the video, as well as subscribing to our channel. So let's get started with Linux here. And then we just have some of these examples. So the Linux command cat -n hello.c will just concatenate or displays like a type command on Windows. Cat command displays -n means give me the line numbers. So in this one, it shows line number 1 through 7. This pound include is the header file. In this case, we're including the standard IO input output .header file .h. And this is C++. And I mean, sorry, on C. And C++ as IO stream is the header file, equivalent to standard IO.h. These are upward compatible as well on C++, but C++ is a superset of C, which was written in C purely in assembly language combination. So if you look at this example, as you can see, the first line is saying that include the standard IO.h, and then the line number 3 is int, which returns the function main as a value of returning a integer, which is return 0 here on line 6, meaning if everything goes well, it is going to return 0, meaning successful. Every command you type in on Linux, pwd echo $? Will return 0, meaning that that command successfully completed. If the command fails, that return value is non-zero. So this return is saying that if it is this statement is executed, it is there. In order to compile this one, you say gcc -o, and you gave the name hello as executable file, and then the source is hello.c. And now I have two files, hello and hello.c. As you can see that The hello just got created October 20 right now at 1:30 Eastern time. So this one is basically showing that read write execute by the owner, read write execute by the group, and read and execute by other people that are not Lutfi and group Lutfi. So this file is executable file. So now if I just say hello, basically it just says this statement inside printf statement. Printf is a function that is defined in the standard IO.h. It is going to just write this string with a bang at the end of it, and this new line character. New line characters is going to just write a return character after the bang or exclamation mark. Similarly here, welcome to MyWebUniversity, it writes all that thing and then just goes to a new line character and then returns. Now, since the program succeeded, if I say $ question mark again, it is going to return 0, meaning that the program was intended to do that and it did it. So now if I say file hello.c, notice that this says as a C source text file. But if I say file hello, the executable file, it says executable link format there. So for that video that I was just telling you that you watch this one, I explained the executable link format and all the details of it. So you can see that what is this header files of this file and how it is getting compiled, everything. With the GCC, this option of -O, I explained that it's gonna say create an output file with this hello, and at the same time, while this one is the source code, it gives the source code, it creates a .a. If I just don't put any .o option, by default, it will create a.out. For example, GCC hello.c, it already created the a.out, and a.out is equivalent to hello. And that program, the binary, they are the same. So if I do ls minus l hello, ld hello, and then a.out, they're both executable files, and look at the size of them. So whether I run a.out now or hello, it will just do the same thing. But the only difference is hello is a meaningful name. A.out is as a default name for it. So I'm going to remove the a.out here. And then notice here, I have a number of files. So if I just want to do the hello there and then say, okay, I like this one, but what if I just want to put a different string here? So let's just copy how easy it is to just duplicate a template. Now we have written hello.c as a student. You could just say hello, let's say my channel, my YouTube channel. YouTube channel.c. So this is saying that hello.youtube channel. Now we do use vim to modify hello YouTube channel.c. VI improved, or vim is the utility that here we're using to open this file in an editor. And this one is saying that on line 1, I'm already setting the line. So if I say set no in you, the line number goes away. But if I say set in you, the line number shows up in order for me to show you exactly what I'm talking about. So line number 1, it has an include. I'm not going to modify that one. Line number 3 is exactly okay. And line number 3 also sometimes have this int argc and then char for character argv. And then array of varg. But you don't need to just, by default, if you don't use the kind of like reading the parameters from the standard input or to write the value back or reading it, the arguments from the system, you don't need to have those ones defined. So no parameters are passed into the program. So here we're just writing hello word, and instead of hello word, let's say we say hello, and then we just say a couple of messages. And instead of this, say welcome to C programming language. C programming language. And then we did that one. We could just go on another line and just say, welcome to my web university free educational videos. So this will just say those two messages. And then if I want to just have one more new line character here, just to separate our command line from the last command, which is right here, wlutfi@mywebuniversity.com. This is my command line. So the ls minus ltr star.c, notice that when you do ltr, less the files and ascending or descending order recursively, the last file that was modified. So this is the last file that was modified. So I'm going to say now cat minus n hello underscore ytc.c. And then if I just do the same thing with file on it, that's also a C source code, right? So now if I want to just compile it to say gcc minus o hello, and then ytc for a YouTube channel, and then the source name is again hello underscore ytc.c as the source file. Now we have a file called hello underscore ytc as executable format. It automatically sets the executable format because of the umask. Umask is set to 002. That means 7 minus 0 is this first read write execute 7. This one is also 7 for the next one, and then that's 7 minus 2 is 5. So read and execute. That's how that one is translated to in that one. So now I say hello YTC is going to say the two message, welcome to my web university free education videos, as well as welcome to C programming language on the first line. So and notice that this two new line characters, it prints a new line here and a new line here. So that's why we have two lines to separate this prompt from this one. Okay, so coming back to this program, if I just go modify it, I could do anything with it. But notice that file hello underscore ytc is an executable link format. And similarly, if I say gcc minus gcc, and then I just don't give any name, I say hello underscore ytc, the a.out is going to get created. GCC hello dot I have to give the extension of .c. I missed that extension. A.out is now going to do the same thing, and A.out was created. File A.out, you can see that. Okay, so now I'm done with these two programs. I'm going to delete the executable because I can always create the executable. So I don't need to just keep these files. If you have the source file, you can always create a new executable file. So the next example I want to show you is the for statement for the for underscore demo.c. Clear a screen vim for underscore demo1.c. And this one is only 14 lines. Again, a standard IO header file, we're including it. This is a comment section. If you do multi-line comments, this is how multi-line comments is there. A single line comments and C and C++ is one line like this, and this is a comment. Okay, so you could write that one, and if you just want to do more than just one line, you could just also press enter here, this one, and then here you say, for example, program name. You could say the name of the program for underscore demo1.c, and then written by Wahid Lutfi. And then you could say copyright, for example, let's say anything you want to do with it, copyright MyWebUniversity.com. So you could say something like that, and then date that you want to write, anything you want to write it. Now this is the comment section, line 3 through 7 will not read by the compiler. Since I have a typo here, for loop, and then I'm just gonna do XX and then just add a P here, and then just save it here. Save it with the lowercase w. So and main here. Now this one is just basically defining a constant called max. This max, you could just define it to any number. And then I want to just print between line 1 to 10. So the for statement has 3 expressions here. The first expression, int number is equal 1, defines this number to be initialized to value of 1. And the data type is integer. And then the semicolon is a must. And then the second one is number and then some expression that check for a condition. If number is less than this value of max, which is defined up here. If max was not defined, then the program would not work. It would give you max is not defined. You have to define it earlier. Otherwise, you could put the number 10 here. You don't want to just constantly put values in it. Sometimes if you're using a constant, define it up here and then do it. So this second expression is for the condition matching, and third expression is either incremental or decremental. And you can increment before the value or after, post or prefix. So you're just doing it. This one is a line of comments, just the 2 slashes like I was showing you earlier. And then the printf statement is printing it, and then printing the number with %d is replacing the digital or integer value, and f would be floating point, and so on. %s would be a string, and so on. You could just look at the syntax of man printf statement with section 3, and then you will see all the details. A return is successful. So now we have done this one. Let's just say file for _ demo1.c. It is a source code, and now we say cat -n for _ demo1.c. So it's 18 lines, and then we're going to say gcc -o for _ demo1 from the source code for demo1.c. That's compile it. Now file for _ demo1. If you just do this one, it says asterisk, means show me both. And then the same thing, instead of the file, if I just say do a file on both of them, and the first one, which is a demo1, is executable length format, and the second one .c is a source text. So that means that I can run the first one, say for _ demo1, because I compile it and it prints the numbers. This is the for statement that does between the. Notice the for statement, you're incrementing it here every time within the loop. You initialize it here, you check for the condition here, and then you increment it by 1 here. So it goes from 1 to 9, up to 9, and then it stops. And if you want to just change it, vi for _ demo1.c, and then all you have to do is, let's say you want to do it for 100 numbers, you could do 100 here, and then just recompile it. If I just run it, it's going to only run up to 10 because I modified the source, but I need to recompile it in order to get that working. So now this is the recompilation. Now for demo1 got recreated. Now it's doing it for 1 to 99, all the numbers. And if you just want to see them on one screen at a time, you can do a 5 more so you can see all the numbers. Okay, so let's just do another example. I'm going to do rm for _ demo1, and we don't need the executable again. So this time I'm going to show you the example of for _ demo2. vim for _ demo2.c. And then this one is a little bit longer, 19 lines. But again, this is still a simple example. In this case, I'm just introducing you a floating point number, an integer data type within the same main function. We're using a for statement on line 10 that the expression again starts where initialization of number is equal 1, num less than max, and then num incremented by 1. Then as soon as it prints the value, this time I want to say the number plus the number is equal what number. So here this number is going to be written as this value, and then that number is going to be, the second one would be this, and the third one would be as a result of number plus number. It would be this. Similarly for the multiplication. So the two first is the first two digital replacement, and that after the equal sign is this combination of number times number. Similarly for the subtraction. And then the floating point that the decimal, divide by, I'm just declaring a variable of 2.0 as floating point. So any number that I give it, I want to divide all of them by 2.0. So we don't have a non-zero value, first of all, because division by 0 is not allowed. This one is using a constant 2, but it is a floating point, because this number usually either the numerator or the denominator has to be a floating point number in order to return a floating point number. So we could get exact number. We don't want a 2.5 to be just written as 2, or a 1.5 is written as, or 1.99 or 1.3. So we want that 2-digit value. But because it is, let's say 9 divided by 2 is 4.5. 8 divided by 2 is 4, so on. So let's just run this program. And this one was example of for demo. So cat again minus n for underscore demo2.c. We're going to just do that one. We're going to say, okay, gcc minus o for underscore demo. And then the source code is for demo2.c. And then now we created those two files. So we're going to just say, let's do a ls minus ld on this. And you can see the first one is executable link format. The next one is read write, because it's a source code. Source code does not need to be having executable file format. So if you do a file on it, you can see the first one is executable link format, but the second one is source code. That's why we have permission of 4. That's the same permission, read write by the user and group, and others read only. So now we are going to just say, go ahead to do the for demo program. And notice this one, I'm going to do a pipe more so we can see one screen at a time, because the values are there. So the value of number is 1, and then 1 plus 1 is 2, 1 times 1 is 1, 1 minus 1 is 0, 1 divided by 2.0 is going to give us 0.50. Similarly for the 2, and then the division is 2.2 is divided as 1.0. Similarly for the 3, you can see 3 times 3 is 9, 3 minus 3 is 0, 3 plus 3 is 6, and 3 divided by 2 is 1.5. So all the way up to the last number, 9, and then 9 plus 9 is 18, and 9 times 9 is 81, 9 minus 9 is 0, and 9 divided by 2 is 4.50. And that's how this program for the for statement works. So now I'm going to just compare for statement with the while statement, because anything we did the for statement, I'm also doing similar program with using a while statement. The syntax is the same. You only need one of them, honestly. If you want to write a program only using a while loop, you can do it. You don't need a for loop. But if you want to do it a for loop, you can do it. You don't need to use a while loop either. But there are times that you prefer one of them versus the other one, and it's up to you how you make that judgment. So that's why both of them were provided. So now if we just do vim on while underscore demo1.c, and then this one is 16 lines. Again, the standard IO is there, the comment is there, and main is there. These values, data type of int are there. And then this one, because it's a while statement, while is going to check for this condition. If this condition is true, it enters the while loop. And then in order to exit the while loop, this condition has to just be false at some point. So while a number is less than max, which is 1 less than 10, yes, it is true. At some point, because you're incrementing it, the value becomes equal to 10. Since I'm not comparing less or equal to, then as soon as it becomes 10, it stops. So it goes up to 9 number. And then that's what the while loop here does, similar to the other one. So the in comparison, if you notice, this int num was not defined here, but on the for statement we moved this one in the first expression. Then the second one was this expression with semicolon, and then the incremental that we did. I'm sorry. This one was the first expression. This one was second expression. Both of these one were a semicolon within the for statement, and this was the incremental value. So this is how you can translate that one into a for statement. Let me be a little bit more clear if you did not understand me. Like for example, if I just translate this one to a for statement, you would say for the first line 8 is say int number is equal 1, and that would be your equivalent to line 8. Then you say the number less than max, that's equivalent to that line 11. And then you just say line 14, you say number plus plus, and then just close this one. And then you start the brace and then close the brace. You would have these statement inside here. So to y, you could do this. And if I just want to show you that two numbers, we are going to say here, just let's do a printf example of for statement, for loop. And then we just put a new line character here, and then just do that, and then a semicolon here. And then this one is we are going to do another one, example of while loop. So now we have done both of them similarly, and then we are just looking at it. The number is equal 1. But notice here, the number is int is number is equal 1. And this one example is already checked. And then within this number, we got out of this for statement. The number is incremented right inside here, right? Inside here, because this int is getting inside this loop. But the value is set here. Let's just run it, and then we see if this is affected, or this is the scope of this number inside the for statement as we have done it here. Okay, so let's just compile this one. We're going to say GCC plus, I'm sorry, minus O while underscore demo1, and then while underscore demo1.c. So the code ran, and then file, and these two files got created without any issue, and they're both executable. I'm sorry, file those two executable and source, and then we are going to say just run while underscore demo1. And notice this one, it says example of the for loop. This one I didn't need to do it, but I just wanted to show you how easy it is to convert it into one versus the other one. So you can switch between a for statement within a while statement, or vice versa. And this is an example of while statement printing the same thing. So here 1, 3, 5, 7, 9. What happened to the rest of the number? So let's just look at that one. While for the for loop, we're missing something. Let's just see what happened here. So we are saying int number is equal 1, num plus 1 there, and then example of this one, we're going to Okay, I'm gonna just declare because this is another. I'm gonna declare two different variables, num and number one. One is I'm going to use for the for loop, and the one I'm going to use for the while loop, just to be safe, and then so I don't modify the same number on the second loop, and then just because it must have jumped into the next one and add up the number within that loop. So it should have just done this loop first before it does the other one. But let me just say that this is a num. So num is equal 1, and then we are going to print that value, and then compile it. I believe this was the compilation with GCC right here. And then to run it, we run it like that. So this one is still 13579. So why is it coming with 1397? Now that's a good question. Let's see again what we missed. So we say this one is num. I'm going to move this one right after this, because at this time I did not have it, but num, so num is equal to 0, num plus less than 1, num plus plus, and then number 1. Okay. One, 3, 5, 7, 9. So it jumps in after the first one, it adds up twice. Let me just do something here. There's some reason I'm not seeing it right now. Let me see why. When you do for num is equal 1, num less than max, num plus plus for the value of num is equal, and then num plus 1. So we do print num, and then it should have just done this one. Num is equal. Okay, so while the statement, it looks like it does not exit here, and it just goes to the next while statement right away without terminating this one, even though I have this for statement and this while statement together within their own loop. Let me comment this section to see if this one is just somehow, even though I'm using two different variables, and the way you kind of trace this one, you put a comment section here, and then everything else is already there. You just compile it again, and then you run it again, and then that should say 13579. So why is it even with the one being commented, it is reading it 139? So the first number says for an int num is equal 1, num less than max, and then num plus plus. The value of num is, and then 1 num plus 1. So sorry. Sorry. For the for statement, you don't need this num. That's why the problem is the for statement automatically increments. So I left that one there. This is not needed. That is within the for statement, you're automatically incrementing here. That's a good lesson, actually. I'm not gonna just correct it, and then I just want you to notice the difference. So I somehow I was looking at the code quickly, and I just did not pay attention. But once you increment it here, you don't need that when inside the for loop to increment it there as well. So if I just compile it now it's going to work correctly. And this is how it should print that one. So going back here on the Vim, I'm just going to remove this line and then remove this comment and remove this one. And then now your code is working on both of them the way you want it. So the for statement and the first expression that we put is num1. The second is the condition matching, like we did on the other program, and num plus is that incremental. We don't need to increment it. Something that was left over. Sorry about that one. So that's why it was happening like that. So now we have it, and it should work on both of them as expected. And you see that it is working like it is. The for loop and then the while loop there. So the next program that I was doing is Vim while underscore demo 2.c. Let's not just modify it too much. Here we're going to go the same example, but using a while statement. So that while statement, you can see the number is less than max, then you're going to increment the number until the number becomes equal to the max. Then that condition becomes false and you get out of the loop. If you mess this line 18 here, this will be an infinite loop. You don't want to just do it. Similarly, if you mess the semicolon on the last expression of the for statement, and that would be infinite loop, or just a condition that never returns true there. So here we are going to just never becomes false actually. So right here we're going to do the demo2, compile it, demo2, and then now we say while underscore demo2, and you can see the program runs the same way. Same kind of value that we did with the for statement, except this one is the example of a while statement. And then 9 divided by 2, the last statement is 4.50. So, and then if I look at this file name, just to show you, cat -n, while on this one, this program is basically showing on line 1 is standard IO. This is a common section and main, including main. And then right after that one is all these while statement. The while condition is checking for this condition number to be less than max. So it enters the loop, which is start at line 12 and end at line 19. It does these statements. And then at line 18, number plus 1, it gets incremented. Since number 1 becomes equal to the last, the biggest number max at some point after incrementing it 10 times, then and the 1 become 8 and 9 and then 10 eventually. When it becomes 10, a number 10 is not less than 10. So 10 less than max is going to be false, and then the while loop terminates and program successfully finished. Then we run the while underscore demo2.c and sorry, and then while dot without the .c, we have it. So Vim while underscore demo2.c. Notice that if I just change this incremental to like a large number to 1,000, all you're doing is you're just modifying it between 1 and 1,000, and then you just, if I run this one right now, it's still doing it between 1 and 9. But if I recompile it, because the source code got modified, so now I recompile it, now I run it, this one is going to run between 1 and 99. And then that is 499.50 divided by. And that number plus that one, this one, you can see the multiplication, and this one is a subtraction. I hope you enjoyed it, and then The last other example I wanted to show you is maybe on the infinite loop, vim inf loop.c. So this one I would say was another program that I already showed it, but since we're talking about the while loop, we're going to just show you when you write an infinite loop, this program will never terminate. So be careful when you're writing a while statement. So this flag has to be at some point false. So when you say Boolean flag is equal true, if you say while true, which is while one is always the case, true is true. So that is going to say, and then I say here within the printf statement on line 13, I say set the flag to false if you want to just terminate the infinite loop. Otherwise, this is going to run in definite mode, and then it will never see it. So let's just compile this one. I'm going to show you, and I will show you another screen. I will just open another terminal session here, so you can have both of them. I'm going to just minimize. Let me just make another terminal session with a different color. So I'm going to say terminal, and then just the coloring scheme, I'm going to change it to, let's say, this type. And this is another nice color that I have, and then I'm going to set up this. So this is already there. I'm going to minimize this window a little bit, so you can see the two windows here. The bitwise connection I'm going to minimize, and then the other screen that I have here, I'm gonna just say, okay, go ahead, exit out of this one because I don't want to modify it anything. So now I'm gonna clear my screen, say inf star. So file inf loop.c cat -n inf loop.c. Notice on line 13 I have the flag is saying that if the flag is on set on line 11, that is becoming true, you're getting into an infinite loop. So in order to do this one after printing, you could say flag is equal false right after line 13 at some point. If some condition is printed 10 times, after 10 times, you want to set it back to false. You could do that one. So like we were doing earlier. Here, let's just run it, and then we not show you what is happening. So on the Linux, you can run top command, and then these are the list of all the top processes that are happening. So at the same time, if I just run top on this window, and I'm going to just say top here, notice that there's no program called infinite loop here. So I'm going to just say, let's just do a little bit smaller on this one. I want to just have the two windows next to each other so you can see both of them. And then okay, so this one I'm going to shrink it a little bit, and then that way the two of them are next to each other. And then this one is going to show all the process ID. Unfortunately, the top, I want to see more of the top, because this one needs to be having the entire command lines also. So I'm going to move this one to the below it, and then just increase this line here as well. So now I have both of them on two different statements here, and then you can see that they're all good. In order for this one, I'm gonna give it the full window, and this one, so it's much easier to read. Here I'm going to say ls -l inf loop. Now we have that program, and then notice if I just compile that one, I say gcc -o inf loop, and then the source name is infloop.c. So now I have a file called inf loop, which is the executable, link format, 64-bit. So this one is, if I run this program, as soon as I run it in a loop, notice, let me clear the screen here, cat -n loop.c. Notice on this line 13, I have this one saying that if you want to terminate it. So in order to run it, I'm going to do env loop here, and this program keeps writing that one forever. Notice that now on the env loop, it comes out with this process ID of this number. That number is process ID of it is large, but it comes on the system forever, because I'm just saying that while true, it will never terminate. This will run infinite loops, and then eventually your system is going to bog down because of the CPU only working on this one process. And if you're writing some IO or reading some IO, it is too much work for your system. You don't want to have an infinite loop there. So I'm going to have to terminate this process. And the process ID of it is right here, but I will show you on Linux how easy it is. Clear the screen. We say ps -ef grep -i env loop, and then grep -v grep -v grep, meaning don't show my own grep, only show this executable file of this one. So if I just say on Linux, you could say pwdx of this process ID. Pwdx is print working directory of executable. Then you can see that this program was spawned from a home wlitfi program C. And then I can just do a lot of stuff, lsof -p for that process ID. And then, I'm sorry, clear the screen, lsof, rather than this -p, I need that process ID number. So when you do that, this one, lsof -p, somehow cut and paste, it missed the name of this. So I'm going to do that. And notice that that is actually executable link format of that one. So you could do a lot with it, but at this time, I'm going to just terminate it, and just so we could see that one. And if I do a trace on it, I could do it, but let's just terminate it because at this time, the video is going to be too long. And then on some other session, I will do more on other examples. So while that process is there, I could say kill -9 and that process ID number. When I just press enter, this program will terminate. That program will just stop. So because this infinite loop was in there for a little bit, it did not finish it, but it did kill it. Now that process ID, lsof, again, if I do the same one, no longer on the system. You see, it is not showing up. Or pwdx of print working directory of executable, or running this ps -ef, it's not going to return anything. So that program is there. So if I run top here, it's not going to be showing there. But the minute I start it again, if I just run this again, it's going to start. Notice it's going to come again. But this time it's going to come with a different process ID. This process ID always changes. And then the parent process ID and everything. So I'm going to just say quit, and then say pkill. This time, instead of the finding the process, I'm saying env loop. By the name, I'm going to kill it. The pkill is process kill, and then it says terminated. Now that process no longer there, and then top is clearing, and there's no loop and everything. So I showed you how to do it with kill -9. -9 forcing it. pkill is process kill by the name of the string. In this case, it was infinite loop. So in this example, I showed you how to do some for statement, some while statement, some infinite loop programming, how you compare a for statement, if a statement, as well as writing a hello word or hello, welcome to MyWebUniversity free education videos. I showed you a number of things with C, as well as Unix or Linux commands as well. And you're welcome to watch these videos for details. There's a lot of programs in Python, shells, C, C++, and every one of them. If you go on my playlist, There's videos for all kind of combination of different videos, whether you're doing operating system like Linux or Solaris or BSD or anything, you are seeing those ones. But it's, somehow this cat is also showing up for my daughter videos. So here, these other ones are there. You're welcome to watch them and then enjoy them. And then if you just go to the homepage, obviously, or under videos, you see all of them. And then I have some short, some long videos. You're watching them and making comments and subscribe, and that would be great. Have fun. God bless you all. Take care. Bye-bye.